The first robot war will probably not begin with metal soldiers marching down a street. It may begin in a quieter place. A factory aisle, a warehouse floor, a muddy road where sending a person would be worse. For a century, people imagined robots as artificial humans. They would walk like us, carry things for us, maybe even fight for us. The shape was intentional. The human world is already built around stairs, doors, shelves, handles, tools, and vehicles. If a machine could use that world, it would not need a special factory built around it. That dream is older than modern AI. In 1973, Waseda University built WABOT-1, often described as the first full-scale humanoid robot. It could move its limbs, measure distance and direction, and communicate in simple ways. Decades later, Honda's ASIMO made the idea feel almost friendly. It walked, turned, climbed stairs, and became the public face of a future where robots might enter ordinary life. Then the future stalled. The robots could wave, they could cross a stage, they could do one carefully prepared demonstration. The camera turned off and most real work still belonged to humans. That is the gap this video is about. The question is no longer whether a robot can look human for 5 minutes. The question is whether it can do one useful job long enough that someone keeps using it after the demo ends. In 2026, Figure AI said its Figure 02 humanoid had completed a production deployment at BMW's plant Spartanburg in South Carolina. The job was not glamorous. It helped retrieve and position sheet metal parts for welding. That detail matters. A robot revolution does not need to start with a robot butler. It can start with a repetitive task that is awkward, measurable, and valuable. Figure said the robot supported production of more than 30,000 BMW X3 vehicles, moved more than 90,000 parts, and logged about 1.2 million steps. Those are not movie numbers, they are factory numbers. BMW is also moving the idea into Germany. At Plant Leipzig, the company is piloting AEON humanoid robots for battery assembly, component production, and material delivery. The pattern is narrow but serious. Robots are not being asked to replace every worker. They are being tested where repetition, strain, and logistics create a clear reason to try. This is where humanoid robots become more interesting than the demo suggested. Traditional industrial robots are already excellent, but they usually thrive when the world is arranged for them. The part arrives in the right spot. The motion repeats. The cell is controlled. Humanoid robots are a different bet. They are expensive and complicated, so their value has to come from flexibility. They need to walk into spaces made for people and perform work without every inch being redesigned first. That is the promise behind physical AI. It is not just an AI model answering a prompt, it is cameras, sensors, balance, motors, hands, and safety systems trying to turn perception into motion. The difficulty is easy to underestimate. A chatbot can describe a cup. A robot has to see the cup, reach around clutter, grip with the right pressure, lift without dropping it, and place it somewhere useful. Every mistake has weight. A drop part can stop a line. A late movement around a person becomes a safety problem. A bad grip turns a simple task into downtime. So the breakthrough is not intelligence in the abstract. It is reliability under friction, and that is why the boring tasks are the real test. Warehouses, production cells, inspection routes, sorting stations, and material handling do not make the best science fiction trailer. They are where a robot proves it can be useful. The second test is much less comfortable. War does not wait for perfect technology. Ukraine has shown how quickly unmanned systems can move from experiment to necessity. Most attention goes to aerial drones because their effect is visible and immediate, but the ground is changing too. Unmanned ground vehicles are being used and tested for resupply, reconnaissance, mine clearance, casualty evacuation, and remote support. Some are tracked platforms. Some look like rugged carts. Some carry cameras, radios, cargo, or specialized equipment. Their shapes differ, but the logic is the same. Move risk away from a human body. Ground robots are not magic. Mud, rubble, batteries, signal loss, jamming, and damaged roads make them harder to use than a clean demo suggests, yet limited machines can still matter. If a small vehicle carries ammunition across exposed ground, a person does not have to make that trip. If it checks a suspicious route, a soldier can stay back. If it drags supplies forward at night, it has done enough to be worth trying again. This is the point where the factory and the battlefield start to rhyme. One environment is controlled, the other is chaotic. The pressure is different, but the business case has the same shape. Labor is scarce, risk is high, repetition is costly, and the task has a clear boundary. In a factory, the boundary might be moving parts from one station to another. In a war zone, it might be crossing ground that is too dangerous for a driver. In both places, the robot is not taking over all human judgment. It is absorbing a piece of physical work. That is why the robot future will probably arrive unevenly. One plant tests a humanoid beside a welding line. One warehouse tries a machine for sorting. One unit sends a ground vehicle down a road first. One city tests a patrol robot in a limited zone. To the public, these look like separate headlines. Underneath, they are the same experiment. Can machines handle more of the physical world without having every movement scripted in advance? This is also where the hype becomes dangerous. A polished humanoid video does not mean your home is about to become autonomous. A ground robot with a weapon mount does not mean soldiers disappear. Many systems are supervised. Many demos are staged. Many public clips show the best take, not the failed attempts. Robots still struggle with stairs, soft ground, weather, maintenance, cost, communications, and trust. The old fantasy was a single machine that could become almost human. The real shift is smaller and more durable. One grip, one route, one inspection, one delivery, one dangerous crossing. Each small transfer teaches engineers where the machine is useful, where it fails, and whether people will accept it nearby. That may be the beginning of the first real robot era. Not a perfect robot army, not a robot butler, not one invention that changes everything overnight. A humanoid moving parts beside a car line, a machine sorting packages after midnight, a tracked vehicle crossing mud because the human alternative is worse. That is how robots leave the lab, not by becoming human, by becoming useful.